Hello and welcome. I'm Bill Wake. We're here working on parser combinators. They're a functional language approach to writing parsers, and we've come a fair ways. I think we're going to wrap it up in the next day or two. We've done most of the combinators for simple grammar things, but we've been working lately on one for bind. So late in the day yesterday, we started that and got a little balled up. We're going to do that. We'll do some tests, and we'll also do some grammar examples, a little deeper testing on things. All right, and I have another idea for another combinator. We'll see if we have time for that. Okay, so we left off, let's see. Yeah, so a parser error, and it's just one of those things. Okay, so the idea with bind is it lets you name a parser before you use it. And since that's the case, you can reference, it lets you reference the parser in its own definition. So this parser is digit or negated, which is minus an expr. Expr is the thing we're defining it to be. So we're going to eventually, we'll create the binding, the name, use the name, and then bind the resulting parser into the name. So it gives us a little separation there. And what we expect is that this will let us make a recursive call then, because we can define it that way. What we're getting is this error, okay? And we get these horrible nested, I mean, they're legitimate, but they're just deeply nested, painful to look at things. And I kept thinking, well, maybe I should just pass the .parse method. And I said that to myself about 3 or 4 times yesterday afternoon, and then finally it's like smack on the head. Oh, you should pass the .parse method. We define this thing to take a parser method, not a parser object. Okay, so let's go into bind. Yeah, so this is really a parse function. Probably naming would have helped a little there, but parser function takes input and converts it to parse results. But we didn't pass that in. So I think this, if I call this parser.parse and pass that in, I think that should pass syntactically. Yes. Okay. The other thing I realized was we want to test expr, not parser, because parser, expr is the thing we defined. Okay. So now I think we're in a position where this will fail as we want it to. I don't know how long I would have flailed around yesterday thinking about it. And it's going to fail because our method does nothing. Now, what that tells me is I probably also, it would probably be nice to have one that took a parser. The reason I do the method is because I might have other methods defined that aren't named parse. So this passing the method instead of the parser decouples my code some, because I don't have to have specific types of objects. I just have to have specific types of functions. And, so the function doesn't conform to a protocol. It just conforms to its own definition. All right, the result, I think we're going to get all our input back. Oh, 42 error. Yeah, is that? Yeah, so when you call parse, we just return 42 error. Okay. Yeah, and if we had called expr.parse, I think we'd have a different, parser.parse. We would have a different error, I believe. Because we'd be calling off a parser, so something would be different. No, maybe not. Okay. I guess at the end, it still gets down and calls expr, and then you're stuck with 42 result. Okay, but we do want expr here. All right. Let's see. So this method, then, the problem is we want to call the parser method. Okay, but we haven't defined it anywhere. So what we want to do is, this is probably parser function too. Parser. Let's be consistent here. Parser function. Okay, so the simplest thing I can do here is I'm going to save it. Is the passed in parser function. Okay, and then down. Oh. I thought there was a way to. Oh, it's a let. Okay, yeah, let's make it var. All right, and then down here we want to use it. So instead of calling whatever parse thing we would normally do, we're going to call parser function sub input. And in Swift, that's an implicit return, so returns that. Must be unwrapped up. Oh, yeah. Okay, so is parser function defined? Well, for now, let's just assume it is. Okay. But you can see there's a path through here. If I just create it and don't call bind, then I don't get a parser function, and I'm out of luck. Okay. But we haven't tested that. Let's see if this test passes. Then we can simplify some things, and I don't know. We'll see where we go. All right. Yes, that passes. Yay. Okay. So, well, one thing was I pulled this out because I was getting confused about what the types were and all that stuff, and I don't think I need that now. So we say there's going to be a type that takes ints and returns arrays of ints called expr, and it's either digit or minus and expr. I've just used numbers for now. We bind it. So these three steps kind of create that expr parser, and then we do that. I could probably make one that was smaller. I don't know if I could make it less. I don't know. Maybe not. I could call just like digit followed by optional expression, and maybe call it digits instead of digit, but something like that. It would work, but the types coming out of it would be funny because optional gives us it gives us optional values, a question marks, rather than arrays of values like this sequence operator does. I don't know if that's a mistake or not, but I think we'll be okay. Now let's bind from function. Can define parser later. Okay, let's add one that kind of corresponds to the test we tried to write. Okay, so this is the same except we're going to pass the object of the parser itself. Okay, and we don't have a definition. Okay, yes, we're doing this properly now. Okay. So this is bind. It's not going to take parser function. It's going to take a parser of type parser. Now, do we have to? Oh, maybe this isn't an option. I think. Okay, let's see. Maybe it's not an option. Let's take another parser for an example. Well, I don't want to make this depend on parser. Yeah, maybe, okay, maybe this test isn't so helpful. It's a little weird to need the function, but it's okay. All right, but we can write tests. Bind with no function bound. Well, has exception? I don't know. I want to do a, let's see, if we skip this, maybe this might even be worthy of a comment. Okay. This should fail. I don't know what the failure is right now. I mean, it's a runtime exception from Swift. We won't really get a success, so that's not really a fair. Yeah, come on. Run it for real this time. Thank you. Unexpectedly found nil while unwrapping an optional. Yeah, so this really does deserve to fail, and I'm not sure how to best do that. But there is, I think there's a precondition. Parser function not equal nil. The message is must call bind before parse. Okay, something like that. Missing return. Oh, two statements. It needs a return now. Okay. And I don't know if I've used that before, so I'm just going to see what result we have. Precondition failed. I don't want to get into throws, but maybe I can leave this like it is. Can I leave that untested? Because I can't check it. It's just giving me a prettier message than the previous one. I don't know. I almost want to do one for this too. Okay. Well, it dies on 27, right? So. I don't know. I don't know a good way to do this. He's not going to throw. Am I? Let's see. Build for running. Let me look up this precondition. Maybe there's something I can do with it. Okay, yeah, that's what we're getting. Playgrounds and unknown builds. If it's released, stops program. Okay. Do I think, I don't know. Do I want to leave this test in there just commented? Maybe I do. This is semi-manual test. Check that precondition check. Okay. It's right. So I mean, I've manually run it and convinced myself that it should work. Let's run all our tests, make sure everything's still clicking along. Boy, that's fast. And we have a manual way to test it, I guess. I mean, you really shouldn't forget that. Now, the other alternative I want, well, another possibility, like, should you be allowed to call bind twice? I don't know. What if I take this off? Can I be a let? No. Okay, I guess var or let only is only applies when you are defining it in the constructors. All right, let's make another test, another variation. Okay. Bind from constructor defines parser. Okay. Now this one, I think we can, let's bind digit dot parse. We don't need all this. Okay. Expert dot parse 1, 2. Result is 1, and the remaining input is 2. Expert.bind, we don't need that. Okay, so we don't need this, but pass to a call text, no arguments. Okay, yeah, so I'm saying I'd like to also have a constructor that lets me pass in a parse function, because sometimes, I mean, if I'm doing recursion, then I have to defer it and wait. And maybe this is for recursion. Okay. But sometimes I'm like, maybe I have another parser by a different name. I'm just defaulting to parse, but it might not, I might know the function right now. And so I can bind it immediately. And let's rename this to number, just to kind of make that go. Okay, so this doesn't build because I don't allow it here. So let's do parser function of parser function equals nil. Okay, so that should parse int to expected argument type int. Oh, Oops. Let's just take this off. Simplify what we can. Okay, build again. Oops. Cannot convert array slice int to parse result int to expected type. Array slice int goes to parse result int question mark. Is that saying it can't be question mark here? Let's do this. Init nothing. But if you init with a parser function, a real one, we can't default it to nil. Okay, how's that gonna be? Oh, come on. Cannot convert array slice int of parse result int to array slice int parse result int. Oops. Int. Okay. I don't know if that's going to be strictly necessary. Okay. Yeah, we didn't bind anything. Okay, so let's bind it. Self.parser function equals parser function. Okay. And run again. Whoops. I always forget those. Okay. Run again. I guess I could say immediately. Bind from constructor defines parser immediately. Okay. And I think this may be the simpler form. And I guess I'm wondering, do I really need these? Or can it infer it? Oh, good. Okay, so I need these. Okay, can't infer it there. Yeah. Okay, I guess because this function defines it all right there, it knows the stuff. All right, run all tests. It's so fast. Oh, okay. I don't know. It just 0.1 seconds. I just don't expect it to be that fast, but I guess I'm glad it is. Okay. Now, one more thing I would like to do. I don't know if it matters, and maybe I should not worry about it, but it definitely crosses my mind that you could call bind twice, and then, like, what would happen? Well, I don't think there's any harm because the parser function is self-contained, right? It takes the input and produces output, but there's no state that it's producing with it. So I think that's okay. But I could put a precondition that says, oh, parser function has to be nil if you're going to call bind. But I'll let that be. Okay. So I think we've done bind. Yeah, a little. I don't often have no way to test something, and I don't think I do in this case, because it just hard jumps into the debugger and doesn't escape. I theoretically could let my parsers throw exceptions, but I just don't want to go down that path. Okay. Good. Let's just run it one more time since it only costs us 0.06 seconds. All right. So bind lets us do recursive parsers or call parser methods with a non-standard name. All right. Now, I remembered also we're supposed to be updating our README, and we did not do that. Okay, so we added variations. Let's see, where's my to-do? Bind. Okay, that is today. Okay. Oops. I lost. Weird. This is 11, isn't it? Yeah. I lost 10. August 2nd. Paste this before I forget about it. What happened? Oh, there it is. It's up there. Okay. Oh, it's me sticking this in the wrong place. That's the problem. Okay. Let's do documentation. Okay, so we had array plus same goes to array. Sequence. If P1 is of a type and P2 is an array of that type, returns an array of results. Or if P2 is of a type and P1 is an array of that type, returns an array of results. Okay. Then, yeah, we didn't need to do anything, but these two are real. Okay. Left child of sequence. Okay. We ended up being able to do the question mark thing, so we have this. Optional is okay. And this one Oh, this is an interesting one. It's a repetition as well. Returns tuples or arrays. I guess this is, no, that's confusing. Equals A and repeat B A. Okay. And then this one. Okay. And peak. It's an interesting one. I don't know. Can we say specialized? It's kind of a cop out. This lets you I don't know, preview a path. That's what I was going to say, but this lets you fail early. Rather than go down a long but incorrect path, I guess. Okay. Good. And then our bind, I guess we can call that specialized too. I don't want to say this. Allows you to recursive calls, or, well, how about you can define recursive parsers, or use parsers with non-standard names. Example. And let's take this example from our test, I think. Let's take this example from our test. I'm going to change some names. Okay. Alrighty. Let's commit that. Okay. Trying to decide what's more important at this point. This is probably the next thing to do. I don't know, the name may not be right, but the idea is I'd like a combinator that takes a check function. So this function is going to take in some structure, which is the result of a parse, okay, the output type, target type of a parse, and it's going to validate it in some sense. And I think the easiest thing to do is going to be, if it has no problems, it returns a nil. If it has problems, it returns the location and message, and then we can wrap that up and return that. Okay, so let's start that. Alrighty, so we're checked in. Switch file. This is check tests. The file is check tests. And we need a couple of declarations. Okay. And okay. So what I'm thinking of is the situation where let's say we parse an expression 3 plus 4. Okay, now the parser, it just has sequences of tokens, and then we're going to feed that into something that creates a tree. So it turns into the tree that's like op2 plus number 3, number 4. Okay. And that is a legitimate expression value. So we've turned output of type tokens, strings of tokens and arrays of tokens and tuples of tokens, into a structured object that's an expression, represents an expression. And in fact, it's the expression we're going to use in the interpreter down the stream. Okay. But then there's also an analysis bit that goes on that says, hey, you used addition. We need to do some type checking. Okay. So type check. And in particular, we want to make sure that a plus operator is only applied to numbers. Okay. This version of BASIC we have doesn't do string addition, but if we added it, we'd have to accommodate it. But right now there's a type check for it. So I want to be able to do a type check kind of thing. So, and it can be any constraints. Okay. So, what I want to do, let's define a digit. Let's a 1 equals, let's take our satisfy example from bindus. Okay. Let 1 equal satisfy, return an array. I don't even think I need the array stuff here. Okay. So I'm just matching ones. Okay. And if I call one Well, I'd also like to have a helper function that's, oops, it goes in the class. Okay, function test check validates parse result. Okay. If I define a method, func sum should be even. Okay, and we'll work out what the types are, but I want to do something like parser equals many one or more ones, and then I want to say, and I'm not sure the best, I thought I could do some sort of dingbats or something. Let's see if we can find a good character for it. I don't know. I tried looking for an I, but I thought there was one. Maybe I'm mixing up the. That one's a little too realistic, kind of creepy. I don't know. So I want something that conveys checking, but these don't. Examine. Caliper. See, I think I get to use math symbols. And that's somewhat I like. It's also kind of a pain to type these, I recognize. But if I found something that really struck me as a good thing, I don't know, there's all kinds of funky parentheses and stuff. I mean, these are interesting, but I don't know what they mean. And I was a math major. But yeah, there's just too many branches these days. And I think dingbats we can use. I don't know, none of these really strike me. I thought about something like this. But maybe I'm going to leave it like this. I don't know. I should have a better one. Okay. But what I want to do is I'm trying to convey that you're going to take the result of this left-hand side, but we're going to pipe it through this function. Okay. And I'm going to pipe it through sum should be even. Not the called version, just the function itself. Okay. Yeah, that doesn't even exist. And then I'm going to say parser.parse. If you parse with the input being 1, 1, 1, 1, then check result, check success, we get result. And the expected target 1, 1, 1. And I guess if I have the 2 here, I know it's still there. Okay, so read all the ones you can. And if the sum is even, this thing is successful. Okay, now let's... this... needs to take some thing in, I mean, it's got to take the left hand's type, which is array of int. Okay, so values of array of int, and it's got to return something, which is, I think it's an int and a slice. Let's find our parser. Yeah, array slice of input. We're dealing with ints. Okay. And this thing is optional. Okay. So, yes, that's legit. Okay. So this function, I'm just going to return 1, 3 for now. Okay. So I am returning a tuple. It shouldn't, but we'll get through the rest of this. Okay. Now I need this operator and the whole check. I don't even have a class for it yet. Oh, what's it going to be like? It's kind of like and then keep left. And it's kind of like our pipe. Okay, so it needs a parser type. Check. It's got to have a parser, and it's got to have a function. Where's pipe? Okay, and the function is the mapper. Okay, p.target to value. In our case, it's p.target to our pair. Okay. Value. Oh, maybe we don't need it. Okay. I think we just need p a parser. Okay. So p.input equals p2. We don't care about that, but we do have to define input and target. And we're going to have to define the parser. Okay. Input is p.input. Target is p.target. Okay. And parser of type P. Well, let's build. I think something's public class. Okay. And then, did I mean to do a closure statement is unused? Okay, now I need the function kind of like pipe. Okay. Goes to int array slice of input. And I probably can say target here just to be consistent. Okay. And this needs a checker of target goes to int. No, this is, yeah, int is right. Okay. Array slice of input. Because the int is the failure return. This whole thing is optional. No. The result type is optional here. Yes. Okay. I think that's okay. Let's assign that. And then hopefully it wants to give us a parser stub. We can return dot failure 39 failed. Closure expression is unused. I don't think so. Okay, we're getting closer. We need an operator. And it's going to be very much like this one. Okay, our operator is less than ampersand pipe. We'll let it be like the others. And this is less than ampersand pipe. P of parser. P function escaping. Well, it's got to be this. Goes to check of P. Return P function. And whoops. Cannot find input in scope. Okay. It's a lot of scaffolding, isn't it? But this should compile now. Good. And the test should fail cheerfully. Okay, we get our 39 failure. So the check just hard-coded a failure here. That's fine. All right. Now let's refine this function. Sum should be even. Well, if let's say it returns if let sum equal values dot sum dot I guess I can do reduce. but then I have to remember how it works. Reduce 0 plus. Okay. And if sum is even, is multiple of 2, then return nil. Otherwise return, let's return sum.count. And a message. Sum was odd. Why is that ambiguous? Oh, it's not sliced. No, this should be int and string. Because it's supposed to be the location of the error and the message. So let's fix that and check. Array slice input is correct here. No, it's wrong here. String. String. Parse array input returns p input p target. Yes, that's correct. Okay. This is string. Okay. Oh yeah. Int, wait, values. Okay. So I think this is a legit checker function. You give me a list of integers. If it's correct, if the sum is even, I will return you nil. Otherwise, I return you an error pair, which is position of, in some sense, and a message. Okay, and this test should still fail. Same error. 39. Okay. All right. Yeah, failed. Good. I think we're to the point of implementing it. But it's an hour in, so let's take a break. Just like 3 minutes, get a drink, whatever, and pick up from there. Welcome back. Alrighty. So we have our failing test. Basically, it doesn't try. It just returns failure without even trying anything. So let's go make check work. And all this stuff up here, this boilerplate, really, the heart of this thing is this function, the parse function. So what we're going to do is we're going to get a result from the parser. We call parser.parse on, this is input, on input. Okay, so again, we're going to look very much like keep left. Okay, we're going to have to parse it and then decide what to do. So if we're successful, we're trying to get the happy case. So if result, well, yeah, if let success of, let's see, what do we get? We get a value, target, and remaining equals result. Okay, so if the result was successful, We parse the left-hand side, and now we want to run our function. Okay. But let's let parse result parse. Okay. Now let's let function result is well, we want to call our little function checker, which takes the target, which is target, and let's see. So checker of target, it's going to return something. If function result is nil, then we've succeeded. So the parse succeeded, the checker succeeded, and we want to return a parse result. Well, that's really just success with target and remaining. So we're picking up the left-hand side. Okay. Otherwise, we're returning junk. So we're just barely. Let's call this check. Okay. So we're just forcing our way through the happy path, and I think this should work. All right. One test. And let's see what happens if check can't validate parse result returns failure. This one is check validates parse result returns success. Okay, so that one's a check success. This should be a check failure. The actual is result. The expected. Oh, this is all mucky. We expect what? Well, we expect a message. I guess we expect the count and sum was odd to be in our failure. So we expected dot failure. Whoops. I don't know what that's going on with. We expect dot failure, count of 4, 3, and a message. Count was odd. So that was the message. Sum was odd. Okay, and this one let's only pass 3 in. Okay. Validate parse result. Check. How about returns failure when check fails? Check succeeds. Returns parse result when check succeeds. Okay. Satisfy one or more one. Some should be even. Parse 3 of them. We should get a failure with the count. Some was odd. Okay. We're going to get a 39 because we hard-coded fall through there or something. Okay. Now here, all right. So this is the case where the check was not nil. Okay. So let's do it like this. If case let, well, how do I want to do it? If I think it's just if let, and I want to say location message equals check, then do something else, return success. Okay, and this one is return a failure with the location in the message. Okay, so we run the checker. If we get a location message, then we return failure. Otherwise, it was nil. We return success, and we're good. And I hope this passes. I believe this should pass, I should say. It's not really a hope. Okay, so now let's do one more case. Test returns failure when parse fails. Okay, so the failure is going to be at position 0. And I forget our message, but it's something like value was not expected. Okay, so this one should never even call sum, should be even. It should fail right on the +1. Okay, so parse of a 2. All right. Two failures. 39 and failed. Value was not expected. Okay. Now this, we had success. The parse was success. I think we can just return parse. We might have to unwrap it and wrap it. And I think we can make this more clear. Okay. So that's if the parse succeeded, do that. Every path returns. Otherwise, return a failure. And this should pass. Module of my message. Did not find expected value. Yeah. Okay, and now, I don't know if I can. I think a switch statement may just make it a little easier. So let's switch parse case success target remaining. Check. Okay, let's just take this for the moment. Get the top level case first, and then case.failure. This should be unreachable. Yeah. I think I definitely can simplify this. All right. Make sure these run. Okay. And right. So I think this one, the success may also be parse, because success target remaining. So let's return parse. And that should be fine. I don't know, somehow I should be able to fall through these things and just return parse, right? um, yeah, maybe there's a way to do this. It's like if let no, that's not going to work. Okay. Switch parse. Location equals check, return parse. Failure, return parse. Maybe this would be better up here. Excuse me. If the parse fails, return it. If the parse succeeds, run the checker. If the checker fails, return the failure. Otherwise, return the parse. Mostly we're returning the parse. I don't know. Because of all the if lets and stuff like that, I don't think I can make it just fall through like you might in C. Okay, so we've added a check operator that runs a function on a parse result. All right, and let's do our README. And again, this is specialized. Less than ampersand pipe that. I'm probably supposed to escape something somewhere, but we'll let it go. If the parser fails, return the failure. If it succeeds, run the checker check function. If that returns nil, there was no problem, so return the parse result. If not nil, it returns a location and message. Used to return failure. Okay, and again, I think an example is called for. Okay. All right, where are we? Well, bind tests examples will probably wait. We'll see. We've done this combinator, the check combinator, so that's a cool thing. Alrighty. I guess what's on my mind is the tests have repetition. Some of it I think is just an issue with the parse result check. I believe there's a way we can make this better. So one thing we've run into a few times is if, well, I'd like this to be a method, a helper method on parse result. So let's, I don't know. Let's see what happens. Extension parse result. Okay. So rather than being standalone methods, we'll put them on parse result for now. Okay. And you're not going to complain? Every test should be complaining, though. Build failed. Okay, yes. Cannot find check success in scope. And that's on parse result. So I want to, let's see what we can do. I want to say it's on parse result, so I don't need the actual. And I don't have to say int, which I don't want to do. Okay. Actual was self. Target to expected type T. Expected type T. Remaining, expected type remaining. See, this should be the input from parse result, I think. I don't know if I get that. What's the problem here? Cannot convert value of target to expected type T. Well, what if I just said target and input? Should be complaining about, oh, this is what I wanted. Yeah, target conform to equatable. I think I can say that here, where target is equatable. Right. Okay. And this input conforms to equatable. And input conforms to equatable. Okay. That looks like a step forward. Okay, so let me pull the original out. Both the originals. Okay, so we got expected target and expected remaining. Okay. if we have success target remaining, if we don't have success, return failure. Otherwise, check the target, check the remaining. All right. That seems okay. All my tests should be building now. Okay, and I should be able to go down my tests one at a time and find somebody doing a check success. Let's start with satisfy. Okay, I should be able to say result.check success, not pass result in anymore. Okay, are you? Yeah. Okay, so let's find check success. Find all these places. Let's copy this. I think it's so common. I call it result almost always. Well, yeah, let's grab this. Now, this technique of doing an extension on a class strictly for the tests, it's handy. I don't think it's totally obvious. I mean, the production code will not see this check success message, which we don't want it to because it's really a concern of the tests. Okay, now let's run all these tests. That was and then tests. Check successes. I guess we can go to check tests. We'll have to look at these. They may be a way to do them. Because before we didn't have equatable, and now we kind of know it is. But some of these tuples aren't equatable, so maybe it's inescapable. I don't know. Failure. And you can see naming my results consistently definitely pays off in this kind of change. Some of these are probably we didn't have check success defined when we defined the test. And some of them are probably there's a special case that makes it tricky. Whoops, this should be bind test. Okay. I should be able to get rid of the check success outside of my class now. Okay. And I should be able to do a similar change for per check failure. Oh, and I could almost fold these together. Maybe that would be better. Okay, check failure. We're going to have to do kind of the same thing. We're going to take out the target. Actual. Actual becomes self. No question about. Oh. Okay. All right, so I should be able to call check failure somewhere. T could not be inferred. So we took that off up here. Where T is equatable. Parse result entity. Okay. right, now I have check failure here. This one should be unused. Good. Okay. Now, what's funny to me, location and message should be okay. I mean, what I want to say is assert equal self and expected. Can I not do that? Type of expression is ambiguous. So maybe that's why I have to do this. I don't usually add these messages on them, but I think in this case, oops. Yeah, it's a good way to get extra work done. Welcome back. Okay, so I really was hoping I could just say assert equals on my values and have it just work, but this is why I ended up writing the method in the first place. I wonder what's ambiguous about it. Let's try that again. Self and target expected. Parse result int target. Huh. What's funny is we don't even care about the target on the failure case. Yeah, I really wish they would give me more context on their side. Okay. I don't see a way around it. But this is slightly better. Okay. So we made check success and check failure be helper methods on parse result. Okay. And let's see what else we can do with these. Failure. That's okay. And the tests are relatively short and sweet. A lot of them cover the 3 cases that you end up with, which is fine. Oops. Comma tests. Yeah, this test has to be this way because the tuples target is a tuple and they can't be compared by default. I thought they were going to fix that, but apparently it didn't make the top of the list. Now what's wrong with this one? So result. Check failures that failure zero did find expected value. Same issue. Even more annoying. This thing could return a tuple, even though our failure stuff doesn't look at the tuple at all. The type doesn't match. This one we can check this way. Comma left fails to match first item. Let's try this one. Result dot check failure. Oh, now this one appears to be okay. Okay, so we can use that there. These are straightforward tests. That's good. I'm guessing these are. Yeah, I mean, there are 3 or 4 lines. That's tolerable. There's some difference, but I mean, I could pull out set 1, set 2. We use them often enough. Let's try success. These are a little different, aren't they? Yeah, a little specific. I think I can pull the two sets out though. Yeah, again, the types just don't line up for us to compare them. Those are different. Those are different. This one can be done. Probably too many changes. Set 3, set 4. Okay, build. Okay. Did we do or else tests? Yes, and pipe. Specific to that. Satisfy changes. Yeah. Okay. Run all tests. And sat is read-only. The parsers are read-only created once kind of object. There's no difference between them. They don't maintain state, so there's no risk of cross-contamination between the tests. All right, let's get to, what did we do here? Okay, we did bind. Did update documentation. We improved tests somewhat. Okay. Tests. That's what we've been doing. All right. Now, I think let's go on my wish list here. So the last section was examples, and this gets into kind of a programming language design issue. So it's a little complicated, but I think it's understandable. So you define a grammar, and let's say statement can be other, which could represent any kind of statement. But we also have if statements, if expression then statement, or if expression then statement else statement. So this is very standard kind of thing, optional else. But the problem comes in if you've got if expression 1, then if expression 2, then other 1, else other 2. and there's an ambiguity. So there's basically two ways to parse it. One would be sort of parse kind of the innermost thing, let the innermost one be as greedy as it wants. Okay, so we start the first if expr, and because the inner one sees then and else, it grabs them both. Or we could not be greedy, and if expr one, then just the if then statement inside and else other two. This is an ambiguity in the grammar, and actually it's kind of an ambiguity in the language as defined. And the way you deal with it, I mean, the traditional way of dealing with it, I should say, is you decide which interpretation you want, and you require the compiler to do that. And the almost universal rule is let the innermost thing be as greedy as possible. Okay, and so the first interpretation is the one we want to keep. All right. And there's another example that came up with our BASIC interpreter. So you may not be familiar with BASIC. It's you may not wish to be, but a line starts with an integer, and then it has a statement, and then 0 or more extra statements, colon statements. So colon's the separator in BASIC instead of semicolon. So you could have statement, colon statement, colon statement, colon statement. And the statements, we'll just ignore most of them and just say there's a print. And then otherwise there's an if then. If it goes to an integer, then it's really saying if expression is true, then go to that line number. And there's also a statement that's if expression, then statement, colon statement, colon statement. And you kind of have the same thing. If A, then print 1, print 2. Well, if you went and divided things, like your parser divided things by rule 1, like identify the top level statements, then you would say, if A, then print 1 is the top level first statement, and then print 2 is the top level second statement. Or again, we could be greedy down at the lower level. If expression, then print 1, print 2, and we want the second interpretation. Again, we're saying the inner things need to be greedy. Now, in recursive descent, the way we implemented the parser for the BASIC interpreter, this is very easy. You parse the then. Well, let me go back to the previous one. You parse the then and the statement, and then right away you look for else statement if possible. Okay, so if it's there, you greedily take it. If it's not, there was no problem. Neither one has it. Okay, and it just sort of falls out of the recursive descent. It's very natural that you're looking for that else, and if you find it, you consume it. We're doing parser combinators, and they don't like ambiguity. Okay, now the trick is they can handle a little bit, and the reason they don't like ambiguity in a way is because the parser combinator is happy to. It does backtracking if needed. Okay, I think we're going to write our grammar in a way that doesn't really need much backtracking, but it's completely happy to backtrack, and so you could theoretically run every possible matching version on it, and it would find something and then say, okay, I found this, and then it could backtrack and try all the other possibilities and say, oh, I also found this. These two parses are not yielding the same parse tree, but they both are legal according to the rules. Okay, and that would be a problem. Okay, so what we can do is we basically, when we do alternatives, we parse this or this or this, we can say, let's try the alternatives in order. And so if the if then else version is first, we're going to try that first. And if that succeeds, then the greedy stuff works and it's fine. And if that fails, we'll try the if then without the else, and that'll work and it's fine. So because we're trying them not all in parallel, but in order, we can do some meddling, I guess is the right word. We can push, we can set the order in a way that makes it work. It's a little weird because it's not, you have to think about it. You have to have some awareness of it. But really, and what happens in most languages is there are a couple places where you have to resolve these ambiguities, and 95% or more doesn't care. So I'm thinking of C++. I know they had some ambiguity. I'm not sure what they do these days, but templates use brackets, greater than, less than brackets to identify the types. And you could have two nested templates, so you could end up going blah, 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 right, greater than, because the first greater than ends the first template type and the second one ends the second template type. But greater is an operator, it's like a sequence or append operator in C++. And how do you know whether you're supposed to be dealing with a template or with a sequence operator at this point in the parse? Okay, so I know there's an ambiguity there. I suspect they made some rule that says, I don't know the rules. I don't remember now. Either said, oh, you must have a space after a template close, or we'll peek ahead and decide whether you're doing a template or an expression and arrange it there. But, there's little places like that. There's just a few, but, they create trouble because you probably didn't think about them until they happen. And then you may have done it the wrong way at that point. Yeah. So anyway, what I want to do for this part of things, and I don't think we'll finish the next half hour necessarily, but I want to take those two examples and create a little test case that demonstrates that we can write the grammar in a way that parses it correctly. Okay. And I'm hoping we can just use strings and maybe make it not too tricky, or make it a little more readable, I should say. Okay, I don't know why I'm qualifying this. We improved the tests. Is there more we could do? Yes. Okay. Test the dangling else problem. That's kind of its given name. And test the ambiguous, the basic ambiguous multiple statements on a line. Okay, so that's the two big ones. All right. And I don't know if we have a good place to... I guess maybe I'll call these grammar tests or something like that. I might find some more. Grammar tests, and let's import pcombo and rename this grammar tests. Okay. And I guess I could just steal this. Okay, so I'm going to say let other equals satisfy $0 equals other. I'm going to try this with strings and see if we can make this work. I think because we made our test checker more generic on the types, the parse result thing, I think we may be able to get by with this. It was a problem before. Okay, so let if statement, maybe this is other statement, if statement equals, okay, well, we don't care about the if expression then. Let's see, I guess we do care that this thing is recursive. So let statement equal bind. Do I have to give it types? Yes. Okay, so where's my bind? Well, maybe my bind test would be a better choice. Input type, output type. Input type is string, and the output type, I think is going to be array of string. I may have to do some plugging around to make that happen, but okay. So input type is strings, and output type array of strings. Okay. If statement equals, well, let's satisfy. I don't know. Let if clause equals satisfy 0 equals if, and else clause else. Okay. All right, I think we're ready now. Okay, so the if statement is if clause, if, we'll let that represent if expression then, okay, and then plus a statement, plus an optional else clause followed by a statement. Okay, do I believe it? All right. If statement followed by optional else and statement. Okay. And my statement itself, well, let's bind. Statement.bind. All right, and we want to do let's let statements equals other statement or if statement. Let's bind statements.parse. Okay, so grammar's requires types to match, and we will do that with other. Can we do it like that? So we're trying to get everybody that's not going to work, is it? Well, that wraps the other in an array, but this thing is an optional. If clause and statement, we'd like that to be an array. Well, it's a little messy. Maybe I need to put a grammar in. Oops, sorry. Missed your comment, sorry. So what I really want to do with these, I don't want to produce arrays of strings. I really want to produce nested structures. So let's define one. See if I can remember how to do it. Is it indirect enum? I guess I can put it outside. Okay, so one case is other. There's actually another one we haven't talked about, which is skip, meaning an empty clause. And then we have an if. Let's just say if statement, which takes a statement and a statement. Okay, so this is a little different. Enums in Swift are a little fancier than most other languages. It really comes from the functional programming side. But with this indirect enum, we're actually building a tree. We're saying the leaves of the tree can either be skip statements or others corresponding to this, or it's an if statement with a then clause and an else clause. And we need to arrange things so that if the else clause is empty, it puts in a skip. Okay, so we're defining a whole kind of different thing here. Okay, so the deal is we need some helper functions. Let's take this one out. Okay, so well, this one, it does do something. We want to transform it. So if you match an other statement, we want to return a dot other. Okay, because that's a statement type. All right. Hopefully it can infer the type there. Cannot infer type. Okay, statement dot other. All right. So we're matching a string and we're converting it into a statement. The if clause, the else clause, I don't think we care there so much. But we want to say if statement, then build, let's say build if statement is a function we need to define. Okay, undefined, right. So build if statement is going to be a helper function. Build if statement. It takes something, I don't even know how to say what, but it produces a statement. Okay. And that should help something. Okay, here we go. Cannot convert value of type. Nothing goes to statement. That's the build statement. To the expected tuple of element array well, it's a mess, right? If clause and statement, that's a tuple because they're different types. If clause is a string and statement is, I don't know what. I guess it really wants to be a statement. Let's get this straight. Okay. So we would like this to produce statement types, all right? Or other does that. But the if statement, it's saying, I've got a string and a statement, so I'm going to make a tuple out of those. And then I have an optional thing, else clause and statement. So else clause is again a string, and a statement is another thing. So there's a tuple for that, and that tuple is optional. Oh, it really is nested deeply. All right, so build if statement. Well, the type is, this is, let's just say argument of, it's a tuple. I think it's a tuple of a tuple. Ugh. Okay, so the first one is string with statement. And then the second thing is, well, the third thing is an optional string and statement. Ugh. Can I get the type right? Ugh, I don't know. And I got to give it a name. No. Oh, okay. Return.skip. It's happy. Okay, good. This is the worst part of these semantic things is peeling them apart because they get so nested. It might make sense to transform some of them. I don't know. But anyway, this is kind of the code we'd really be writing for this thing. So I guess it's okay. All right. Now the argument. Okay. Well, this is going to fail. Well, it doesn't even parse yet. Let's do statement. Okay, that defines our parser. And we're going to say statement.parse, and we're going to give it an array of strings. All right. And that array of strings is this mess. Now, we shortcut a little bit because if expr 1 then, I'm just using the keyword if. So if expr 1 then, if expr 2 then, other, else, other. Is that it? Okay. If, then other, else, other. Is that? Yeah. If expression 1 then, if expression 2 then, other, else, other. Okay. And we want to assert equal result. Well, result should be of type statement. Okay. And I think if we say it's equatable, since it's built from all equatable parts, it should be okay. And that lets this thing work. Okay. And what we expect is an if statement containing an if statement containing, and let me put this on a separate line so we can build up a tree. If statement contains two things. It contains a statement. Well, if the inner one matches, this will be other, other. And the second one will be a skip. Okay, so it should put a skip in. if it can't find an else clause. Global function requires conforms to parse result. Oh yeah. Well, I want to say result. Okay. If result equal, let's see. Target and remaining equals result. Else XCT fail. Result. For me, I have to do. Okay, if it's not target and remaining, then do that. Well, I want my target to be this, and I want my remaining. Apparently I've missed a parend. Good. XCTAQ remaining to be empty. I'm surprised it didn't think that's ambiguous. Okay. Whew. All right. Yeah, so this is why I made these big tests, or said they were big tests. All right. So if expression, then if expression 2, then other, else other. Okay. If other, else other should be an if statement with two others. So we should have picked up the inner ones and a skip. All right. And now it's on this thing. We're going to get the wrong answer. We'll get a skip because that's all we're hard coding here. Skip is not equal to our complicated thing. Okay. Now, I think our grammar is close enough to that. We can get by without it. Okay, so how do you build an if statement given this complicated structure? Okay, so, well, we don't care about the strings. I don't know if we can do this. Let's say ignore the string, statement 1, else clause. That pair equals argument. Can I do that? Okay. So I've got statement 1. If else clause how about if let ignore statement 2 equal else clause. Okay, so if statement 2 was defined, so if the else clause was defined, then we want to return an if statement with statement 1 and statement 2. Okay. Otherwise, the else clause is nil. If else clause is nil, then we fall through here, and we want to return an if statement with statement 1, because we always have an if clause or then clause, and the statement 2 is a skip. Okay, so an implied else that does nothing, and somebody's not happy. Skip is not equal to, oh, that's just the test. Okay, so I think this is legitimate now. We'll take the argument, we'll ignore the string because that's just the if clause. We'll look at statement 1. We'll look at the else clause. If it exists, then it's got statement 2, and we'll return both those. And if it doesn't exist, then we must add a no else clause, and we skip. Okay, and my hope is this passes. Okay. Wow. Cool. It's a lot of work, isn't it? I guess partly because matching is such a tricky thing. All right. Other statement, we converted it to a statement other. If clause stays a string, statement is a statement. Else clause is optional with a statement. Okay. And this is what our semantic routines are going to look like. They're going to have these, they might have arrays in some cases, but they're going to have some ugly nested structures. Now, let's see. I can improve this, I think. Okay. So if I have an if clause, like, do I need to keep the if clause? Like, what if I only kept the statement? And I only kept the statement. Okay, now my types are wrong, but I'm only keeping, I've got a tuple of statement and optional statement. Okay, so now this is a statement and an optional statement. Okay, and so I don't need to worry about state. I can say let then clause else clause equal argument. Okay, so that's the two statements. If else clause equals else clause, then I do then clause and else clause. Otherwise, I just do then clause. Okay. I think this will pass. Right. So yeah, you can see this operator we added that ignores things. That helps simplify this stuff. So this becomes down to much more essential things. I do wonder if the else clause returning an optional is helpful or not. It would also be possible to return an array of 0 or 1 items, but I think if you ever blended it with anything else, you wouldn't be able to tell which one it was. Okay, but this is tolerable. Most things aren't any more complicated than this. And some of our multi-match things do a lot better. Okay. Cool. So we've checked that our parser handles the dangling else problem. And that's a good thing. All right. So we will stop here and pick up tomorrow. It's Eastern Time, 10 a.m. to 12:30 p.m. or UTC 3 to 5:30 p.m. Otherwise, I'll let you make your own adjustment on time zones. But this is a nice, realistic problem. It's approximately what we would do in a real situation. I mean, this if statement looking like this and a builder to run from it, that seems very realistic. So it's a moderate but good test of our stuff. And tomorrow we'll pick up with that other problem, which was the basic ambiguity. And since we're doing a basic interpreter, knowing we can solve that problem will be a good thing. All right, even if the test is a little long, I think it's got the pieces we want to see. So thanks for joining me, and I hope I catch you in the future. Take care. Bye-bye.